We are going to review some factoring skills and then apply those skills to solve for some very strange looking equations. Trust me, you will see this in Calculus 1 many times and your teacher is going to think, oh, well, you know how to factor. I know you remember your greatest common factor. And you go, well, that was something easy. But have you ever seen anything like problem 1? And I ask you to factor it. Believe it or not, you're going to look for what's called the greatest common factor. So if you look at these two groupings, here and here, do they have anything in common? Well, yes, they have a 2x plus 1 factor, and they have a 3x minus 1 factor in common. But it's raised to these weird powers. What do? Well, let's take out that 2x plus 1, and we always want to take out the smallest power because that's what they're going to have in common. Let's just go back. If you have 3x squared plus 5x to the fourth, you would take out the x squared, that's the smallest power, that's what they would have in common. So the smallest power between 3/2 and 1/2 is the 1/2 power. Then we would take out a 3x minus 1 to the 1/3 power. But what would we have left? Again, let's go back to this first grouping. Well, we would definitely have the 4. We would have a little bit more of 2x plus 1 because we only took out a half. So what are we doing here? We're dividing. We're having 2x plus 1 to the 3/2 divided by 2x plus 1 to the 1/2. So our rules of exponent says you keep the base and subtract that. Well, 3/2 minus 1/2 is just 1. So that would be left to the first power. Factoring is really dividing. Then we took out all of the 3x minus 1, so we don't have any of that left. Plus, let's look at that second group. We would have the 3. We took out all of those, and how many 3x minus 1s would we have left? Well, we need to subtract those exponents, and lo and behold, that's just to the first power. So yes, that's my answer. Let me just write it a little bit clearer. But let's see, I think we can go ahead and multiply that out. So let's make that an 8x plus 4 plus 9x minus 3. And then let's collect like terms. Let's see, that's going to be 17x plus 1. And we have now factored that completely. Let's look at the second one. Same idea, just remember negative is smaller than positive. So we're going to look at this grouping and that grouping. They both have a 2, so I want to take that out. It looks like they have a 4x minus 1, and if I look at those exponents, the smallest is the negative 1/2. And they both have a 3x plus 5. Looking at those exponents, the negative 1/3 is certainly smaller. So we've canceled out the 2. We have a 4x minus 1. Alright, so let's come over here. We have a 1/2, that's that. And we need to subtract what we took out, which is a negative 1/2. So 1 minus a minus a half is 1. Another way to look at that is if you multiply that back out, you would keep the base and add the exponents, and negative 1/2 plus 1 would get you back to the positive 1/2. And then I believe we took out all of those. So now onto the second grouping, took out the 2, took out that, so I have a plus 3x plus 5. Want to guess what the power is going to be? Yep, it's going to be to the first power. Because again, 2/3 minus a minus 1/3 is positive 1. So let's clean this up a bit. And then we're going to do one other step. So if I can collect like terms here, since that's just to the first power, I'm going to be 7x plus 4. Now that's okay, but can I also write it like this? take those negative exponents and put them in the denominator and make them positive exponents. That's going to become really handy as we start solving equations. So I want to solve that. Now we need to apply those same skills to start solving these equations. Those look kind of scary, but let's first of all rewrite this as 6 times x plus 1 to the 1/2 power instead of using that square root. Hopefully you see a lot of x plus 1's. Well, let's first of all factor the numerator. And what are we going to take out of there? The smallest exponent, which is the negative 1/2. So we'd have x plus 1 to the negative 1/2. That's going to leave me 6 times x plus 1 to what power? What do I need? A 1, because I would have 1/2 minus a minus 1/2. What I started out with, subtracting what I took out. That's going to leave me a first power. Minus 3x plus 2, and then I took all of that out, all divided by 4 times x plus 1. Of course that equals to 0. Now let's look at this and this. Those are the same. Remember on the last example how we took the negative and we brought it down? Well, that's what we're going to do here. So that's x plus 1 to the positive 1/2. We're going to clean that up, but let's look at that top part. Let's distribute the 6. Let's distribute the minus. And on the bottom, what can I do with this? Keep the base and add the exponents. So looking better. Let's collect like terms. So I have 3x plus 4, and that's my equation. Now how do you solve that? Think about this. This is a fraction. The only time a fraction can equal to 0 is when the numerator equals to 0. The bottom can't be 0 because that would be undefined, but 0 divided by anything equals 0. So we're going to set the top equal to 0 and solve for x. And yes, you will be doing that in Calculus 1. You have to do a lot of steps before you get to here. So that's the part you need to understand, the skills, before you get to Calculus 1. Right, on number 4, look at that numerator. We have lots of things we can factor out. So I'm going to take out the x plus 3 to the negative 2/3 and x plus 2 to the negative 1/4. That's going to leave me an x plus 2 to, yes, the first power, 3/4 minus a minus 1/4. You're kind of seeing that pattern. That's going to go away. Plus, then I have an x plus 3, again to the first power, is 1/3 minus the negative 2/3 is 1. Taking out all of those. On the bottom I have x plus 2, multiplying that together I get 3/2 equal to 0. Now just like on the last example, since those were negative, I'm going to put those in the denominator and I'm going to collect like terms in the numerator. So I have x plus x, so that's 2x plus 5 on the bottom. Now you could put those together, but since we're just solving for when this equals to 0, when does a fraction equal to 0? Only when the numerator equals to 0. So I have 2x plus 5 equals to 0, so x is negative 5/2. Now this last one looks kind of weird. I agree. First of all, why would you ever have that? Well, trust me, you're going to be writing something like that, and then the next step is you're going to simplify it. So 1/3 times 3, yes, is 1. So let's see. We have this and this in the numerator. Do we have anything in common? I believe we have a 3x minus 1 to the negative 2/3 in common. So that would leave me 2 times 3x minus 1, but let's be careful. Let's see, 1/3 minus a negative 2/3. Yep, that's to the first power again. Then minus 2x plus 1. That went away, that went away, that went away. All divided by this. So again, that's going to go downstairs, and then we need to distribute. Let's see, I'm going to have a 2/3. I'm going to take that down and have another 2/3, so that's going to be 4/3. Collecting like terms on top. And solving for x, because just the top makes that fraction equal to 0. So just a good basic algebra review getting you ready for next semester.